So in this video, I want to talk a little bit about word problems and some of the types of word problems you might see when you are doing decimal operations um, or fractions operations. So I'm going to talk about three common types and some of the strategies that you can use to help you visualize what's going on in these problems. So let's take a look at some of the types you could see. So the types of problems that you might see are unit rate problems. These are problems where usually they're asking what is a better value. So for example, if you're buying 6 apples that cost a certain amount from one company, and then you're buying the other deal at another store is 4 apples for a different price, which company, which store has a better value? Which one would be less expensive? So we call those unit rate problems. Another type that you might encounter is a average per day, per week, per a certain amount of time problem. So these are asking you if there is an average amount of, for example, rainfall per day, what would be after 1 month, what would be the total rainfall in a month? Or if Bob mowed an average of 3 lawns per day and he made $5 per lawn, how much money would he have after a week? So these are asking us to find out, based on an average, what would be the end result after that amount of time, a set amount of time. And the last type of problems, these are called proportions problems. So these are asking you to find out a relationship between two different values. In other words, how many times does this value go into this value? How many of these fit inside of here? So we're going to take a look at all of these individually. So the first type, let's zoom into the unit rate problems. Okay, so I've set up a problem for you to think about, and this is asking about apples. So if we have store number 1 is selling 3 apples for $3.30, and store number 2 is selling 5 apples for $5.65. Which one is going to be the better value? Well, in these types of problems, it's really important to visualize what is going on in this problem. I recommend drawing a picture to help you understand what's going on in this problem. Now, really, what this problem is asking us is, how much does this store sell its apples? What is the cost per apple? What is the cost per apple here? So in other words, what we're going to need to do is take the number of apples, take the price, and divide the price by the number of apples. If we divide the price by the number of apples, we will be able to tell what the price is for 1 apple. If we take the number of apples here and the price here and divide by the number of apples, we'll be able to tell what the price per apple is here. Okay, so in this case, we would set up this problem as 3.3 divided by 3. And if we were to do that, we would see that each apple in this store cost $1.10. If we did the same thing on this side, we would set it up this way. $5.65 divided by 5, build our wall. Each apple at this store costs $1.13. The better value is the cheaper value. That means that the first store has a better value by 3 cents. This store is more expensive by 3 cents. We would prefer to shop at this store. So again, this is how you would solve a unit rate type problem. So the next type of problem that we are going to talk about are the average per day, per week, per month, per year type problems. These are asking us if there is a certain amount that is repeated for a certain number of time, how much will be at the end? So we're given a part, we're told how many times that amount or part will be repeated, and then we're asking for the result or the end of something. So an example problem that you might want to look at is this. If it rains an average of 4.4 inches per day for 30 days, how much did it rain after 30 days? So this is basically a repeated addition type problem. It's asking if we repeat the amount 0.4 30 times, because there are 30 days in this amount of time, in this period, how much will that be altogether? So in these type of problems, usually if we're trying to find out the total at the end after a certain amount of time, that tells us that probably we're going to be doing repeated addition, or we can use multiplication to shorten the process. So to set this up, we'll take our amount that's being repeated, then we'll put our time that it's going to be repeated, or our number of times that it will be repeated, and then we'll simply multiply. So we'll add a 0 here for our place value for our 30, and then 3 times 4 is 12. Okay, and then we would actually use a jump strategy to pull this over. So the answer would be, it would rain 12 inches in 30 days. 12 inches in 30 days. These problems might also ask you, if it rains 12 inches in 30 days, on average, how much did it rain per day? Now, because they're giving you the end or the result after a certain number of days, you could find the answer by simply dividing by the number of days. For example, 12 inches in total after 30 days divided by 30, and you would be able to get the number, the average per day. The last type of problem that we're going to talk about is proportions problems. So proportions problems are usually asking if you have a certain part of something, a certain part of a whole, how much of that part will fit in a whole? Or it might ask you, if you have a whole and you have a certain part, how many parts will that be? So basically, these are problems that are very helpful if you draw a picture to represent what it looks like. So in this problem that I'll show you is there is a white background border. The border is 182 7/10 inches squared in area. There is a small picture that is on average 9 inches squared. How many of these pictures roughly will fit into the white background, the white board? So again, these problems are very helpful to visualize. I always draw a picture with most word problems to help me understand what's going on visually. If I represent it this way, I can understand that this small thing is going to fit into this big thing a certain number of times. That tells me that I could divide this by this. It's a division problem. How many of these go into this? Divide this by this. If I recognize it that way as a division problem, then I can begin to start estimating roughly how many of these will fit into this. I can use my estimation strategies that we've talked about before. I know that this is about 200 and this is about 10. I know that 10 goes into 200 roughly 20 times. I know my answer is going to be very roughly around 20 times. However, if I want to get even more specific, I can say that this is about 180, and this is exactly 9. I know that 9 goes into 180 about 30 times. So this tells me very precisely what my estimate would be. I can go ahead and set up my division problem and solve it. 182.7 divided by 9. I don't need to do anything for my divisor because it's